provide technical services to our members and to the broader building industry and to government. We have members and staff and instructors located right across Canada. The most exciting thing I find with Passive House, I'll wander a bit here for a second. One of the most exciting things I find about Passive House Canada, the photos here are of real Passive House Canada members. And this is a group of people that loves to share. They love to share problem solve together. You know, by day, they may be fierce competitors, but by evening, they will hoist a coffee or something stronger and try and solve problems together. Really great group of people, and I would encourage you, if you're not a member, I'd encourage you to join. Moving ahead, you know, what's our mission? Our mission is fairly simple. It's to make zero emission buildings known and adopted by government, industry, and the public. It's to support government and industry in the transition to high performance buildings through education, certification, and policy development. We promote the Passive House Institute building standard because it's globally recognized as the best building standard for high performance buildings. So that's our mission. Moving ahead, very simple question. Did you know that the world's lowest energy and lowest emissions buildings are also healthier, more comfortable, affordable, resilient, and contribute to a sustainable future? And that's why Passive House Institute is recognized internationally, as I said, as the proven best way to build for comfort, affordability, and efficiency. The standard is performance-based. We'll be talking more about Interfit later on because we spend a lot of time talking about new buildings, but we know if Canada is to reach its climate change, its carbon reduction targets set in the Paris Accord, that we also have to spend a lot more time, a lot more energy on retrofitting, deep energy retrofits of existing building stock right across Canada. We'll touch on that with our guest today and the Tower Renewal Project. But I love to use this photo on the bottom right to very simply explain the old building from the 1950s and the building today. So we need not say any more. We'll learn more about what the Tower Renewal Project is up to and about Ken Soble in a bit. So today's guests, as I said, Graeme Stewart and Yael Santopinto. Graeme's a registered architect, a principal at ERA, and he's one of the key initiators of the Tower Renewal Project. I'm really excited because he's a Jane Jacobs Prize Award winner for his work in this area. And Jane Jacobs is someone who I never met, but certainly read her books and was a great influence to me, especially when I was a municipal councillor. And Yael is a registered architect at ERA. And she's also Director of Research and Partnerships with the Center for Urban Growth and Renewal, and that focuses her work with the Tower Renewal Project as well. So two very smart, very experienced folks on the show today, and I can't wait to get to the interview. But before we get there, some of you may be saying, what's a Passive House? What is Passive House Canada? I just want to touch on the five fundamental principles of Passive House. It is a super insulated building envelope. Our second principle is that you use high quality windows, and if you can, with solar orientation. So the building uses solar energy in the wintertime to heat itself and is protected from that solar energy in the summertime to help stay cool. That you have a really good quality ventilation system with heat recovery, and that the building is thermal bridge free. So there's no easy way for the heat to get out or the cold to get in. And perhaps the big star goes beside air tightness. And that is something that I'll touch on in a second because there's Canadian roots there. So if you build better to these five principles, you will feel better. You will have year-round stable indoor air quality and temperature. You will have a very quiet and comfortable building throughout all the seasons. There will, of course, be a substantial reduction in energy use and operational costs because you'll have simpler mechanicals. You'll have systems that are very simple to use, very durable, and that all adds up to giving you priceless peace of mind. So very quickly, those are the 5 principles under Build Better, and they make you feel better to live and work and play in a passive house building. Moving along, you know, Passive House Canada has, or Passive House Standard has Canadian roots. It has Canadian DNA. This is the Saskatchewan Conservation House, built in 1977. It was built during a time with an oil shortage where Canadian governments of all levels were worried about how Canadians in this cold climate would heat their homes. They took the best science of the day through NRCan and through the Saskatchewan government to build a demonstration house in a very chilly part of Canada to see if by applying current building science, they could make a home that used very little energy. And in 1977, Canadians were the leaders. This is an example of that building science in play. Our very own Harold Orr, an engineer, recipient of the Order of Canada, was one of the key players, especially around insulation in this building. We had him on the show a month ago. We're going to have him back on the show in a couple months from now to talk about his current work. Harold is in his 80s and still going strong. But here's his work and a group of really smart people from 1977. So Passive House Standard has its DNA. Within its DNA, it has Canadian roots. And I'm always so proud to talk about that. So I want to get on with a conversation with Yal and Graeme. And there's 2 topics that I'm really interested in hearing about today. You may have more, and as Stephanie said early on, if you want to ask a question, pop it into the conversation, put a Q in front of it so I know it's a question. I'll try and work those into the conversation, or wait to the end. We have a spot for questions and you can ask your questions there, and we'll turn the mics on at that time as well. So without further ado, I've got some slides of Ken Soble that you kindly provided. Can you walk us through this project to begin with? And I'll flip the slides when you want me to, but one or both of you jump in and talk to us about Ken Soble, the Ken Soble transformation. This is a building in Hamilton. It's owned by Hamilton City Housing. But what can you tell me about this building? What can you tell us about this building?
Great, thanks, Chris, and thanks for the introduction. So I'll jump in here and give a brief overview. This is a 1967 apartment tower, 18 stories high, owned by CityHousing Hamilton, who is City of Hamilton's social housing provider. So CityHousing came to us back in 2017 with a vision. They had committed to ultra high performance passive house approach across several buildings in their portfolio. And this one in particular, which was in a very poor state of repair. It had actually been, like tenants had been asked to leave the building or had been leaving the building progressively over the past couple of years due to its poor state of repair. It needed a lot of reinvestment. As they were doing that, they said, well, why wouldn't we actually bring this up to the highest standard if we're already doing comprehensive repairs? What would that delta be? And so we started with a bit of a feasibility for them. The goals of this project, which the project is now almost complete, it will be substantially complete in about 6 weeks. So we're just moments away, and that's where you could see on the far right, its current state, 2021. The goals of this project, there were 4 goals. One, of course, was to maintain its affordability as a social housing building and actually transform it into a seniors building. And so that led us to our second goal, 20% accessible units, but also barrier-free access throughout the building on the site. And that's something that, of course, had not been accommodated within that existing 1967 building. The third thing was we have a tremendous capital repair need, and that meant replacement of distributions, mechanical, plumbing, electrical, but also interior fit out, new kitchens, new bathrooms. There was a lot of interior work that had to be done, including remediating some mold that had built up on the interior of the building. And then the last one, and the one we're here to talk about today, of course, is the passive house. So to say, what is the efficiency of this building, but also what is its comfort, health, resilience outcomes for its tenants? And so with those 4 goals in mind, we worked closely with CityHousing Hamilton to develop this project.
Great, and it's a beautiful looking project. You know, a building built in 1967, lots of wear and tear, lots of deferred maintenance, I suspect, having had experience with social housing all across the country. And a really big project, and some gorgeous pictures you have here. So what were the key challenges for you going forward with this project?
Graeme, I'll pass it on to you.
Okay, great. Well, we're really thrilled to be where we are now, and so over the weekend we actually finished the final all building air tightness test, which, as your 5 principles showed, is one of those things you need to achieve to get certification. So thankfully it passed with flying colors. The air tightness metric that you need to get certified for PHI is 0.6 air changes per hour, and we were able to achieve 0.2. So quite a
that's amazing.
Yeah, we're
amazing.
Very pleased.
Yeah.
So round of applause to the broader team. But I think what was amazing is this will be the largest Interfit. So Interfit is the certification for retrofit outside of Europe, and by far the largest in North America. So we're really thrilled, and it has a lot to do with the vision of the client. And one of the things around that, as we were involved, our expertise really is tower retrofit for resilience and for decarbonization, a real push to say, don't tear down your assets, reinvest in your assets, with the real metrics of minimizing social impact, that it is significantly less expensive to refurbish than to replace, in terms of capital allocation, but also in terms of a carbon impact. Demolishing embedded carbon and then rebuilding it is a huge, is environmentally unsound. So with all those principles in place, in addition to the requirements coming from the owner to say, well, let's achieve that by doing passive house, it really is a first of its kind in Canada. So the challenges were, are we ready? Is the market ready? Is the supply chain ready? And it was because of that vision to sort of plow through and say, let's do it, right? And I think what we found, and we're really thrilled by, is here we are, we've done it. And almost all of the products used in this are Canadian or through Canadian supply chains, save a few which have Canadian distributors of Swedish heat exchangers or what have you. But one of the things that's really interesting is that we've done quite a deep dive on analysis. One is a case study we're working on with CMHC, which was the state of affairs of this project, which you can download from our website. We're also engaging in a longitudinal study with civil engineering at U of T and CMHC to look at this building for 2 years around how is it actually performing. So there'll be lots of data coming, which will be exciting to share. But what we found through that is if we undertook this project even 2 years ago, we would not have been able to spec a lot of these products. So the market is growing very quickly. And in fact, if we went to market today versus 2 years ago when we went to market with this, we would have been able to spec products that weren't available. So things are happening very quickly. And so one of those is windows. So in this image, you see these windows. Those are made in Canada, made in BC. And one of the things that we think is so exciting, the BC step code and the real signaling in that province around requirements for passive house for municipal buildings and for other pieces is the market's responded, and there's Canadian manufacturers who are building these components. That was not true 2 or 3 years ago. So we're excited about how does that then scale? How does the whole country begin to adopt some of those similar requirements? Like the Toronto Green Standard is going to basically require passive house within a few years. And we're hoping that that means that more of these projects will happen and there'll just be more market readiness.
Right, right. Excellent. You made so many good points. I know here at Passive House, it's been a remarkable transformation to from sort of a theoretical, this is coming, to us now saying this is here. You know, market transformation is happening right before our eyes. This isn't some theoretical idea that may or may not happen 2030 or 2050. The number of passive house buildings under construction in Canada, under renovation in Canada, has never been greater. And here's an example, you know, of the largest retrofit passive house enerfit project outside of Europe, right in our own country. And as you said, you know, the components are Canadian made or Canadian supply chain. So the ability to do it and to do the biggest in North America is right here. We've got the technology. Clearly, we've got the people who know what to do, and so we're looking forward to this. And I know the marketplace. I know government is very interested in passive house because we can do it right now. So congratulations on the air tightness testing, by the way. That's when we're supposed to send up fireworks and the whole bit to congratulate you, because that's a heck of a mark that you hit. And I can only imagine some of the challenges you faced, technical challenges you faced to do that in this building. I've got a couple of people are asking me questions. That why don't I throw a couple out right now? Susanna wanted to know whether it's obvious, but were the exterior balconies enclosed?
Yeah, I can speak to that. So no, they were not enclosed in this building, and I think this opens up a big issue of addressing thermal bridging, complex bridging in existing buildings. We know that concrete balconies that are through slab connections essentially act like radiators in most buildings in Toronto and Canada, really just letting out all of your heat and of course being tremendous thermal bridges. In this building, we looked at a number of options, and we worked to sort of model how those might perform, but also how we might tactically do them in our market. So we looked at wrapping those balconies, at enclosing them. And we are just seeing now some products on the Canadian market to enclose balconies, which is a practice that is of course very commonplace and off the shelf in other jurisdictions, especially in Europe. But on this building, and mostly for operational reasons, the decision here was to remove the balconies and actually replace them with Juliets, so as you can see in the image on the left there. So that decision, as I said, had mostly to do with maintaining accessibility for people not needing to step down onto balconies, and also as a preference from City Housing. But those solutions will be required, and a number of solutions will be required, like enclosing and wrapping, and potentially removing and replacing with thermally broken balconies elsewhere. Just wanted to also mention how buildings like this actually have a number of thermal bridge challenges that are unusual, and that you sort of pick up during the design phase and think, oh God. Well, so one of them is the garbage chutes, which, again, passive house being a European standard, garbage chutes are not common, and in fact are often not permitted in a German building code context anymore, but they actually act like an enormous thermal bridge through the building. Same with rainwater leaders from your roof drains. So those kinds of things were interesting challenges to tackle. And again, you thinking of our building typologies here in a North American context needed some nimbleness.
Right. Fascinating. I've got a couple of questions here. And you've addressed part of it, but what were the most difficult thermal bridges and how did you solve those issues? So a couple of questions there. And you've touched on garbage chutes, the balconies. Maybe those were the two most challenging thermal bridge issues.
It's interesting. Those were big challenges. I think, something we could talk about that's on the screen is the way that the envelope was constructed to mitigate thermal bridging. So you can see on the right at the top there, there's an image. Oh, there's an image of the envelope under construction. And, just want to also use this opportunity to say that the dexterity and nimbleness of the trades on site and the constructor, PCL, really played into making this a high quality construction. So if you go back to the next slide, I think, you'll see exactly on the top right, you'll see a window going in. So here, and not to get too technical, but here to say, we had a building that was a masonry building, had a lot of variation. Of course, it's not a flat plane. And so what you'll see painted on top of the brick, that gray color, is actually a fluid applied air barrier, cementitious air barrier that was applied to the building. And then windows were installed outboard of the building. So in 6 inches of new mineral wool insulation. So, so that angle approach to installing the windows allowed us to kind of deal with variable existing conditions in the rough opening, but also have really good control over all those membranes and mitigates thermal bridging. So those are fiberglass.
Great.
There's a lot of details in there that required a lot of players to come together. We had on-site trades training. We initiated a sort of air boss role on site to monitor that airtight layer and make sure it wasn't being penetrated. And so there are a lot of precautions that had to happen, not just through design, but all the way through construction to really make this sing. Mm-hmm. And everybody needed to get trained up in Passive House, and they did.
And they did. Good, good. And we're focusing a lot about, obviously, on Passive House and Interfit and how you've met those standards. One of the questions that's come up a couple of times is looking at heating and cooling. We talk about Passive House, and we always seem to focus on keeping you warm in the winter. Did you have to do any special calculations in terms of keeping you cool in the summertime? Did you have to do anything special with this building for cooling?
Yeah, maybe. Yeah, maybe I'll tackle that one. Absolutely. I think what's interesting also is while Passive House has these deep Canadian roots, it does have current requirements that are essentially based on the local context of Middle Europe. So right. In terms of the assumptions, as you was saying, it's the Middle European Building Code, that assumes no interior thermal bridges like garbage chutes, but it also assumes the temperate climate of Austria or southern Germany, less humid, less cold, etc. So when you look at our climate zone, it's colder and it's also much more humid, and that's in southern Ontario, let alone Edmonton, let alone further north. So we did opt both for owner requirements. This is a seniors building, but also due to an abundance of caution to put in an active cooling system. And what's interesting is we modeled the performance on 2050 climate projections, and we kind of had a high and a low variables. Of course, those are all assumptions, and those projections change every day, but at least we held ourselves accountable to those sort of future scenarios. Mm-hmm. And as you mentioned, it's pretty easy to keep this building, warm in the winter with enough of a fur coat, right, or enough of a winter coat. The other piece, and I saw a few questions sort of pop up, is the window wall ratio on this existing building is only 18%. So it already is really well designed for that perspective. These buildings are great candidates for Passive House renewal. And when you look at the image on the bottom right, these windows are still top to bottom. They're huge. There's a lot of natural light that happens. So even though it's such a low window wall ratio, they're very generous in terms of the lighting, which is great. but it also meant that there was a real risk of overheating in the summer. So it is the way we tackled air changes is we used the centralized system that existed already, but extended it with direct ducting into suites, made sure that that direct ducting was direct fresh air coming from heat exchangers, which is also in the COVID context, something that we're really thrilled was done. So this is a seniors building. This will be direct fresh air delivery and isolated from, isolated unit to unit with a real focus on health and comfort. And the centralized cooling is dehumidification and a light cooling. So it's not bringing things down to going to the mall 21 degrees C on a hot August day, but rather bringing things down to about 26 degrees or so. So more in that range of comfort, and we modeled it based on are we able to ensure that in 2050 we won't have overheating in different exposures, and that's what it was based on. So we're quite happy with the results. So from a resilience perspective, how does this building type, as you mentioned, really allow for mitigating overheating risk, which we know is a real risk in these buildings in the summertime, and also ensuring people are really comfortable in the coldest day in February if the power goes out. So this is a much more resilient and healthy infrastructure. So we're quite thrilled.
Yeah, and that's the dehumidification plays a key role in making your home much more comfortable with a bit of light. There's just there's so many questions coming in. People are really excited. I'm trying to keep up with them. Where's one here? I had a really good one that just came here a minute ago, and it's one that is the big takeaway from today. And Harvey wants to know, what lessons learned would you say could be used in other builds, multifamily, single family retrofits? So what are some of the key takeaways from your experience here? This, the largest passive house Enerfit project outside of Europe. If you were doing it all again today.
Yeah, I mean, fantastic question. And there are so many lessons learned. And would also, afterward, we can send around some links to a case study that's just been published.
Perfect.
Supported by CMHC that actually looks at some of those lessons learned. Certainly the need for many different players, for this to go smoothly, many different players need to be on board. And so that goes from an owner who's committed with a vision to sort of meet this standard. We all know how during construction it can sort of, as things get complex, targets can fall out the window when we're not holding ourselves accountable. Passive house is one way of actually holding ourselves accountable to a minimum standard that is quite remarkable, and that sort of kept everyone with a clear charter through the project. But there's certainly that side of the constellation but all the way, let's say, to the building department, who in Hamilton, because Hamilton is actually and has become this side of the Rockies, the heart of passive house in this side of the country. And so Hamilton, there have been a number of housing projects, new and retrofit, that have been certified or are passive house designed to the passive house standard, to the point where the building department, the building inspectors have actually gone and had training. And there were a couple of alternative solutions required here that the building department was then able to sort of understand the need for and work with us to review. So we talked about the owner, the authorities having jurisdiction, of course, the design professionals and our team, and then on the execution side, contractors and trades who are understanding the goals of passive house and I think what you can see here is that this is all very traditional construction. Nothing about this is actually a spaceship. This is a building with a lot of insulation, 6 inches on the outside, 4 inches on the inside, but it's a traditional eaves system, and it is a just about everything about it is quite traditional. The air tightness may be the one thing that is unusual from a site perspective, but even that, as you can see here, was achieved through quite straightforward means, not a lot of membranes and tapes and fussy construction details. And so having everyone on board, understanding that this is actually just a energy retrofit plus. We did some crunching of the numbers to understand how much of the budget of this project was allocated towards passive house. And we think it lands somewhere around 5 to 7%. The energy and all of the energy measures put together, probably including passive house, probably about 20%. And the remaining 80% of this project really was a state repair and asset renewal. Meaning that this is a capital project with a passive house on top. And so it's interesting to think how so many players coming together with a sort of understanding of what high performance measures entail can make this a smooth process.
Right, right. And of course, whenever you talk passive house, the 800-pound gorilla in the room is additional cost. What's the additional cost? And, I think we're proving time and again that to move to the passive house standard is not a substantial amount of money, quite frankly. Maybe not as much as it was in the early days. A lot of that has to do with the local expertise that's been developed, the local products that are being manufactured, far more sophisticated supply chains to get the right components to folks like yourself when you need them. So that price differentiation, the passive house tax, whatever you want to call it, is shrinking year by year. And I think what fascinated me about following this project through was that how much of the total cost, as you said, was really about doing things that would have to have been done anyway. Regardless if you were going to that high Interfit standard or not, the mechanicals, all of the replacement that had to be done. So, just a note for folks listening in that that the cost differentiation between a passive house and a regular is shrinking, and it's shrinking year by year. And I hope one day we'll get to the point where there is no cost differentiation. In fact, it might cost you less because of the integrated design process that you have to go through and getting things right at the beginning and fewer changes to fewer work order changes, we'll say, as the project goes along. So all sorts of exciting things happening here in Canada, here in North America, as we all get more experienced with Interfit buildings. So we've got, I've got another slide, the final slide with regards to this building that looks like it's some technical sorts of things here. And I don't know, do you want to walk us through generally or tell us a little bit about, because I know we've got a lot of technical types on our website today or on our webinar today who'd like to know a little bit more. So just explain this slide.
Sure. And we apologize. The writing is very small, and you can get larger versions of this in the case study and in other.
Right.
What we're looking at here is the original, looking at a unit and looking at the original condition and what the repair scope needed to be. And then we looked at what we did to it. And this is actually looking at one of the 20% of units that were converted to barrier free. And I think, as you were saying, Chris, the idea of what is that premium? If the objectives of a project really are to address resilience, to address health and safety, to bring in accessibility improvements, and as a comprehensive retrofit, that doing it through the Interfit process, there's really no better way, because it ticks all of those boxes and does it in a straightforward way. I think when some people are comparing, it's really not apples to apples, because they would be comparing really a like for like replacement of a building that does not meet today's health and safety comforts, does not meet resilience targets, and does not meet particularly fresh air supply and those types of things. So if we're looking at bringing something up to those standards versus bringing it up to those standards with Passive House, then the delta is very small. And then in terms of better, faster, and cheaper, that's the goal. How do we skill up? And I think what's exciting about this project is that it's done and people can kick the tires. They can speak to those trades and actually say, how did you do it? And so one of those, when you look at this image, in the gray version, you have the original masonry, the original balcony, and some amazingly inefficient 1960s windows, single pane, aluminum, non-thermally broken. And so we put a big winter coat on the outside. Originally, it was going to be sort of a double ply layer of a very thick outboard insulation. We found through the project, unfortunately, there was pervasive mold on almost every interior wall surface. So that was quite a surprise to find. And so there needed to be dramatic remediation of every interior wall. And at that point, the idea was, okay, how do we make a lemonade out of a lemon and simplify the envelope construction by moving 4 inches to the interior just with standard studs and bat. So that's why it was a double ply on another project. Of course, we wouldn't want to disrupt those interior walls, and we put it all on the outside. And then the windows, the Canadian-made windows that are replaced there, and then and then the direct fresh air from the centralized ERVs brought into the units. So that was the scope of what we'd say both met health and safety as well as Passive House specifically. Then there was a whole series of objectives that are non-Passive House that were really owner requirements. One, providing sprinkling throughout the building. So these buildings are typically not sprinklered, and so that was to say, how do we bring these up to code? How do we make them safe, especially post the Grenfell tragedy in the UK? On that note, we used rock wool, which is a non-flammable insulation for the exterior and the interior, including bringing in sprinklering throughout. The other, completely, required and invisible and locked behind the walls, is 100% plumbing replacement, both of sanitary and water distribution. So that's just an amazing amount of work throughout the building. And also in this, you can see that where the washroom and kitchen are on the top one have flipped over because part of the goal here was meeting 20% barrier free. That is not a small amount of work. That is major renovation. We were able to do that because the building was unoccupied. And that in and of itself is an entire project, again, independent of the Passive House, which was a major part of the capital, but also will really allow this to be a resilient building. So those are some of the features. There's many more, but all in all, it's quite a transformation. And one thing we wanted to note, if you go to the slide, just came to mind, if you go to the previous slide with the photographs, again with comfort. So when you look at the bottom slide, you see a ceiling fan. So we did a lot of modeling, dynamic comfort modeling for different exposures and different times of year. Because you have a Juliet that can open the full way, and because you have these wonderful Passive House windows that can they're tilt and turn and allow for a lot more air movement, opening your windows and putting on a ceiling fan can really dramatic the perception of comfort in many climate scenarios. Where unfortunately, a lot of these buildings right now, you have these sliders, they're tiny, you can only move them the little 4 inches and you get no air movement. So in this case, we'll get a lot of air movement, a lot of comfort, we'll keep people comfortable before we have to turn on that central cooling system.
Great. When does the building become fully occupied? Have we got a date for that yet?
Yeah, so that date is still being set, and we'll keep you posted.
Okay, super. I know that's one thing that people have been asking about, so I thought I'd ask it. The other, just to address, is a few people have asked whether or not this is being recorded and they can share it. Yes, this session is being recorded, and we post our building conversations to the Passive House Canada YouTube website. That will be great. You know, we could carry on, I think, for the rest of our time talking about Ken Soble, the transformation of this building. There's so many lessons learned, but there is a case study, a technical paper, a review that you mentioned earlier, and we can point people to that, and it will probably answer a lot of the technical questions that are flooding in the question section right now, because people are really keen to learn about this, the biggest Enerfit project outside of Europe. Congratulations again on that. What I wanted to do was turn our attention, though, for the next little while to something that perhaps is even bigger than one project, and it's many projects across Canada. And that is the second interest, the second topic for today, the Tower Renewal Project. And here the Tower Renewal Partnership. Can you tell me a little bit about that and how you arrived there and where you want to go from there? I don't know if this is the right slide, Yal and Graeme, if you want me to move to the next one, or if you can kick off our next topic about that Tower Renewal Partnership.
Okay, this is where, you know, the Zoom etiquette, who goes first? So I guess I'll provide a context, but so
Great.
it's really interesting. So we're really thrilled that we're able to play these dual roles in that, you know, through ERA, we have a practice, it's a retrofit practice, and we do, you know, the entire practice is focused on existing buildings in a variety of ways. And the part of the practice that we really focus on is deep energy retrofit in housing. But to complement that, through the Tower Renewal Partnership, it's a nonprofit, and it's really a collaboration space to be able to move the needle on this. And I think without the Tower Renewal Partnership and the great set of partners we've had through it, I don't think we would have been able to get to a place where Ken Soble was possible. So for about the last 10 years, there's been sort of a really critical efforts, a lot of collaboration with municipal governments, with provincial governments, and with the federal government, especially CMHC. And a slide like this is really looking at the national scale of our aging housing stock, and specifically larger buildings. Canada is unique as compared to the US in that there was a massive apartment boom, both public and private, in the 1960s and 70s. And the vast majority of our purpose-built rental housing is that stock. We haven't built any more for all the reasons, you know, people know about. One of which is in the 1980s, a lot of the federal programs that made it attractive to build these buildings were disappeared and moved over to home ownership incentives, such as writing off your capital gains on sale, right? So it was a real shift to promoting ownership versus promoting the building of rental. So this is the stock we have, and we firmly believe we have to maintain it. We cannot lose this stock. And so that's sort of the genesis of Tower Renewal. And then similarly, when we looked at the fact that a city like Edmonton, let's say, has the landscape in the suburbs is dotted with these high-rise buildings, or along the Saskatchewan River, you can see all these buildings in downtown Vancouver and Winnipeg and Metro Toronto. Where if you look at that versus cities like Atlanta, cities like Chicago outside of downtown, you do not see these buildings. So this is a Canadian, in North America, this is sort of a Canadian phenomenon. How do we keep these buildings going? And then you have the resilience agenda, the decarbonization agenda, the housing crisis. It all kind of coalesces to say that this is an amazing way to put our efforts in meeting these complementary goals. So Ken Soble is sort of a convergence of this to the highest standard at this moment, which is fantastic. But it is sort of a spotlight project within a constellation of others that are happening around the country. You know, several dozen of these by Toronto Community Housing, by BC Housing, and by real leaders in the nonprofit sector working through FCM that has a fantastic set of programs, CMHC through the Co-Investment Fund that's really enabled this first generation of deep retrofits. And so what we're excited about is really saying, you know, This is proving the case. What are then the learnings of that first generation to scale and to get to the second and broader group? And that gets into everything you've mentioned around supply chain readiness. How do we make sure that the learnings of this are normalized? And the best part of it is we're, in typical, I don't want to be disparaging, but kind of in typical small C conservative Canadian fashion, we're not necessarily, even though we invented it in Saskatchewan, we're not necessarily early adopters to scale it. And there's in the UK, in Germany, in many other jurisdictions, thousands of buildings have been retrofit. We can cherry pick the best ideas to scale it here. And now with Ken Soble and some other kind of spotlight projects, we've caught up and are starting to surpass it. So what is the Canadian cross-country approach?
Right, and I think why Passive House Canada is happy to support the work of the partnership is we've said from day one that new building, upgrading the National Building Code to address new builds is very important, but we're not going to get anywhere near our carbon emission reductions unless we address towers. And quite clearly, you've got the data. You've got the experience. Here's your next slide that I think speaks exactly to that governments have to address the tower issue, those aging towers that need to be renovated anyway, most likely. Facades are crumbling, the mechanicals are being patched up. And if you're going to invest millions on a building to fix it up, it doesn't take much more, if anything, to get to that interfit standard. Would be my pitch anyway. So certainly thank you for the hard work that you're doing. So have you got have you got a sense of the number of buildings across Canada that fall into that tower renewal need? What sort of research can you give us? What sort of details do you have?
Yeah, no, it's a really important question. We know that there are at least 740,000 households living in buildings, apartment buildings built before 1985. The number before 2006 gets you closer and closer to a million. And I think those numbers are likely underreported, and we are still kind of finessing, but we know that those numbers are tremendous and that they span the country. One of the things that's really important to bring up about this impact slide, which is compelling from a GHG perspective, to say, there are 3 megatons of carbon to be saved potentially on an annual basis. Great, but carbon is an important policy objective, but it's actually not the most pressing concern for a person living in, for the tenant or for the resident. Right. And so what we've always said, and this is what's so fantastic about low carbon, ultra low carbon retrofits, is that energy savings are actually a secondary benefit. The primary benefit is healthier housing. It is more resilient housing, and it's more comfortable housing. And when we lead with comfort and resilience, carbon follows, and everybody sees the benefit.
Right.
It's a really interesting question, that I think really needs to be spoken to here is that, Ken Soble is an example of a tower that was sitting empty that could therefore have tremendous amount of work done to it. But the towers we're talking about scaling this to are all fully occupied, and it is not reasonable for them to be decanted for a retrofit, nor need they be. We just wrapped up a really a study we're really excited about. You can find on our website. It's a field guide to retrofits in occupied buildings. We partnered with Acorn, who worked with us to do engagement with people living in rental housing across the country, as well as some industry partners, to say throughout the life cycle of a retrofit, how are occupants minimally disruptive, and what is the role that owners, contractors, and residents themselves can play in actually stewarding that. And so finding ways to do what can be complex construction with people in their units is a critical next step to scaling.
Mm-hmm. Yeah, absolutely. It's very complex, obviously, but I like the fact that you brought into play this is more than carbon savings. If you're living in these rundown, broken down apartments, worrying about greenhouse gas emissions is nice, but it's a bit out of your control. You need a place that's safe to live in, that's resilient, that's comfortable, that's healthy for you. And again, you know, the plug for passive houses that it was originally established as a comfort standard. It has its ISO certifications in that. But if you build for comfort and you build for health, and you build for quality assurance, lo and behold, you get a passive house building. So kudos for recognizing that early on. What next for the Tower Renewal Partnership? What are the things you need government to get on board with? And let's throw that to industry as well. What do we need governments of all levels and industry to recognize to do?
Oh, what a great question. And it relates to something that I was just thinking of as you were speaking. One is, what are the objectives and how do we codify those objectives?
Yep.
So we know that there is no retrofit code. You know, there's some loose guidance, and I know that's moving forward nationally, but there's no retrofit code. So often what happens is that it's up to practitioners like ourselves to use judgment for best practice, you know, and owners. But meeting base code requirements does not get you there. So that's one. What are the guidance around the philosophy of how we engage in retrofits? And as you mentioned, that's why interfit is so fantastic. You know, not to be, you know, cheeky or hyperbolic or whatever, but it is very easy to do a retrofit for low energy purposes that has unintended negative consequences for comfort and health, such as making an airtight building where you don't improve ventilation, right?
Right.
But that put in as a principle in terms of a retrofit, you know, for comfort and health, is cooked into interfit. So that's why it's a brilliant guidepost.
It's a whole system. It treats the building as a system, right? So which is rare.
And some of the things that, you know, are getting very technical, but has such an important impact on quality of life is, you know, indoor surface temperature minimums. It makes it so that you are comfortable inside your unit, and that's the goal. And the fantastic side product is you save a lot of carbon, right? So this is, so I think one of those, you know, for government and partners and Passive House Canada can be leaders here, is what are the guidance? You know, if it's not interfit, if not every building in Canada can be interfit tomorrow, what is the path to interfit that people can look to be able to say this should be the guidepost? So if an owner is putting out an RFP, they can say this is embedded into our owner's requirements. I think that's a really big one. So we've been thinking about this a lot, and I think that it's an exciting time. You know, we know that the recent throne speech talked about retrofits as an important part of Canada's COVID recovery plan. You know, it's a lot of green jobs. These are local jobs. It's local manufacturing jobs, and it's improving health and comfort as well as decarbonizing. So, you know, let's hit a home run here. And I think that leads to, or our real thinking is that there's sort of two components. One is the owner challenge. The owner challenge being, there is money on the table from government to retrofit housing. How do we get owners to say, great, let's take advantage of this, and to what standard, right? So that's part one. And that's what a lot of the big nonprofits around the country are now doing. And how do we increase the challenge in terms of the level of performance? The other one is the industry challenge, and that's to say what we've found is unfortunately the last people to know about the opportunity are the trades and suppliers. You know, the owner takes a big risk, says this, they raise the funds, they get a design team, and then they bid the job 2 years later. And then the contractor is then going to subtrades, who are the last people to know this project is happening. I think we're at a moment now to sort of set an industry challenge to say, this is happening, this is going to happen at scale. There's billions of dollars of public money being put aside to see these projects. What is the kit of parts that's missing, or that we want to ramp up performance, and get industry looking at meeting that now. And you know, and ideally, and this is how this is how it's worked in Europe and other jurisdictions, is you'd say, okay, we need this component X at this performance level and at this price point. How do we get there? You know, and that's happening in parallel to the projects being funded and designed. So it's time for that industry challenge. We know there's a lot of great suppliers and trades and people that we've worked with and across country. But I think having a targeted sort of set of what's possible, you know, it's the time is the present.
Absolutely. Very good. Stephanie, we're almost at the appointed hour, and we haven't even gone to folks to ask questions. Do we have a couple more minutes that we can get a question in or two, do you think?
Yeah, I think if anybody who wants to stay on, if everyone's got a couple of minutes, let's just stay on for another 5 minutes or so.
Yeah. Questions about Ken Soble Tower that maybe aren't too technical and take too much time to respond, or questions around Tower Renewal Partnership. I'm interested in hearing if people, how interested people are in that. You know, we have one chap who's saying he has 4 RADs going on around him right now. We need to push on that code. Certainly, that's critical. One of the things, you know, to go back to Ken Soble, one of the things that in talking to other social housing providers and looking at you know, styles of windows, types of windows, you know, is there a problem with the, you know, the tilt and turn windows and seniors using them? Was there concern around that? How was that addressed? Maybe it's not a concern. Obviously, it's not a concern. These windows were used.
Yeah, I think it's an important point. Certainly, high quality hardware is the key when it comes to ease of operation on large and sometimes heavy triple glazed windows. And in this case, you know, making sure all that hardware is at a height that can be accessed, say from a seated position,
Right.
be fully barrier free, added another layer of challenge. But that hardware is, as Graeme said, on the market now in Canada. And, you know, Cascadia windows, some people have asked which windows they were, Cascadia fiberglass windows and doors. And so, you know, we were able to meet those objectives in this case.
Good, good. And I know, you know, we're doing, Passive House Canada is working with a number of governments, government agencies, not-for-profit, social housing organizations, and we're helping them as much as we can with technical questions. It's getting easier and easier for us to point to local suppliers of windows and, excuse me, and other components, which is just, I mean, this is literally exciting times because it's changing almost overnight. And I can't stress enough to people who are watching us right now that they get up to speed with Passive House, with Enerfit, because it's happening all around us and right now. Listen, I really look forward to furthering this relationship and building this relationship between Passive House Canada and you folks at ERA and Tower Renewal Partnership. It's so important what you're saying in terms of, and what you're doing, what you're advocating for in terms of tower renewal, greenhouse gas emission reductions, comfort, health, safety, resilience. All of these things are so important going forward. And it really is a once in a lifetime opportunity we all have to make a difference for the next 50 years, quite frankly, in the future of our country and the climate crisis. So thank you for 10 years of having this vision and showing us the way. And Passive House Canada will be delighted to build a working relationship with you and to bring to the table whatever expertise we can and to knock on whatever government doors need to be knocked on to push the message. So thank you very much to both of you for being with us today. And we probably could just continue talking about Ken Soble for hours more, but we know there's the case study on your website. And I think we will have many opportunities in the months and years ahead to go back and revisit Ken Soble and to talk about lessons learned and to continue to educate the community across Canada with what you've learned. And I know that there will be more projects coming down the pipe, maybe even bigger than this one that you're involved with and the Tower Renewal Partnership is involved with. And we look forward to learning about that. So thank you both, and good work. And I will simply say to folks that we're doing these webinars every month. Next month, we have Arnie Sergara from Diamond Schmidt Architects. And Arnie tells us that he has a big announcement to make, but he won't tell us any more than that. So those of you in the know, know, but I don't know. I just know that it's some big announcement that Arnie's going to make on April 22nd, which we know is also Earth Day. So join us then for the Diamond Schmidt announcement and a good discussion with Arnie about their involvement with Passive House. And before I leave, I'll remind you that visit our website if you want to learn more about Passive House, new build standards, Interfit standards, and watch our YouTube channel for this building conversation and many others we've done over the past. And finally, before we go, thank you again, Graeme. Thank you again, Yael, for your passion, your expertise, and your eloquence in bringing this great project to our attention. And congratulations on the air test. That is a fantastic achievement on your part on a building that big. And we're telling everybody about your accomplishments all over the world. And our German friends from PHI are very impressed at what you've accomplished, and they want to learn more so that they can make their standard even more applicable to North American building standards. So thank you so much for all the work you've done. And thank you to everybody who is on the webinar today. Look forward to seeing you April the 22nd. Until then, stay safe, wash your hands, and we'll get through this pandemic thing together. And let's build great buildings. Until then, take care, everyone. Bye-bye.
Thanks so much.